Oh, is this thing on? Oh, hey guys, didn't see you there. This is Matt and Eric, and we're doing our Anything Physics project in space. We're gonna be colliding objects and figuring out the final velocity. Well, come on, let's go. Okay, guys, so this box right here is gonna be sitting here at 0 meters per second. The mass of it is 24,507 kilograms. Now let's check out the other thing. This ship right here will be traveling at 10.9 meters per second, and its mass is 21,219 kilograms. Let's see what happens.
Anyway, the drop goes like this.
So for our variables in this, we're going to have m1 as the mass of object 1, m2 will be the mass of object 2. And v will be equal to the initial velocity of object 1, which is the ship, and v1 will be equal to the final velocity of object 1, the ship, and v2 will be equal to the final velocity of object 2, which is the standing still block.
Since this is an isolated system, the total momentum of the two particles is conserved. P before equals P after, which means m1v equals m1v1 plus m2v2. Also, since this is an elastic collision, the total kinetic energy of the two particle system is conserved. So this means K before equals K after, which is 1/2 m1v squared equals 1/2 m1v1 squared plus 1/2 m2v2 squared. So if we multiply both sides of this equation by 2, it gives us m1v squared equals m1v1 squared plus m2v2 squared. So suppose we solve equation 1 for v2. We would have m2 v times v2 equals m1v minus m1v1 equals m1 times v minus v1. With this result, we would substitute it into the second equation. m1v squared equals m1v1 squared plus m2, all multiplied by m1 divided by m2 times v minus v1, all that is squared, which equals m1v1 squared plus m2 times m1 squared over m2 squared times v squared minus 2v times v1 plus v1 squared. With the substitutions made, we need to expand by multiplying both sides by m2 in order to clear the fractions, which gives us m1 times m2 times v squared equals m1 times m2 times v1 squared plus m1 squared times v squared minus 2m1 squared times v1 plus m1 squared times v1 squared. A standard quadratic like ax squared plus bx plus c equals 0, where a equals m1 times m1 plus m2, b equals negative 2 m1 squared times v, c equals m1 times m1 minus 2 times v squared. With this, we can use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a to solve for v1. Plugging all this in, we get v1 equals 2m1 squared times v plus or minus the square root of negative 2m1 squared times v all squared times negative 4 m1 plus m2 times m1 minus m2 v squared, all divided by 2 times m1 plus m2. Inside the radical, the last term of the discriminant has factors like a plus b times a minus b equals a squared minus b squared. So everything will stay the same, except inside the radical it is shortened down to 4 times m to the fourth v squared minus 4 times m1 squared times v squared times m1 squared minus m2 squared. With the quadratic formula complete, we can simplify it, which will leave us with v1 equals 2m1 times m1 plus or minus m2 divided by 2m1 times m1 plus m2 times v, which we can shorten that down to m1 plus or minus m2 divided by m1 plus m2. From this, there are two different ways we can do this. We can take the positive sign from the top, or we can take the negative sign from the top. By taking the negative sign, it gives us v1 equals m1 minus m2 divided by m1 plus m2, all multiplied by v. With the equation for v1 found, we're going to plug that back into the equation from the beginning, which was v2 equals m1 over m2 times v minus v1. With that, we'd get m1 over m2 times v minus m1 minus m2 divided by m1 plus m2, all multiplied by v. Shortening that down, we'd end up with v2 equals 2m1 over m1 plus m2 times v. Now that we have the equation for v2, all we need to do is just plug in the numbers and we're good to go. The final equation with all the numbers plugged in that we end up with is v2 equals 2 times 21,219 divided by 21,219 plus 24,507, all multiplied by 10.9. After solving this, we get the final velocity of about 10.12 meters per second. Wait, what'd you get? 10.3.